Okay, we did not have homework, so no homework check, no daily quizzes. Instead, you're going to do the that and the that real quick to show me that you actually know what we did yesterday. My rat. Yes.
Is what we're doing. That's what I heard. Yes. You see him on home? Oh yeah. I need this for my daily We do 2 and 10.
No, we do the other ones. No, we do everything.
Those are the only two you don't do. Okay.
Oh, no, we're doing everything. No, he's just like. Okay.
I need a little sign. Sarcasm.
If A is here. So it's the biggest one.
Come on, meow.
Wait, if it goes above 5, does it just say
Do you guys not have your notes?
Dude, I'm just lazy, so I was gonna look at these.
You know what that is in Spanish?
Well, it goes to the 7th thing.
Yes, I just didn't, the reason I didn't think Polynomials, but fine.
First one. If I'm going to name it, I need to have it in standard form first. Combine like terms, descending order. The fact that there's 4 terms tells me it's a polynomial, meaning more than one. And because it's a x to the 5th as a leading term, it is a quintic. Quintic polynomial. Next one, n behavior. If I were to put it in standard form, my leading term is 5x to the 5th.
5x to the 7th?
Or 7th words. Odd. If I have a positive x to the odd, then I know that my end behavior is, as x goes all the way to negative infinity, the left heads down to negative infinity. As x goes all the way to the right, to infinity, y goes up to infinity. That's it. Okay? What? There's a positive 5 there, Haas.
It's on your paper, too. On your paper, buddy.
Maybe you should flip a couple pages. You would know this if you paid attention.
You're going way too far. It's on page 3.
So, yesterday was just kind of an off day. It was just, yesterday was an off day. Didn't quite get through this. We're just going to finish off 5-1, go straight into 5-2, get done whatever we get done. After that, we started graphing them, which was for us by table. I can graph anything by table, right? So I think that was, we just did the one and that was good enough. You all know how to graph by table? Okay. Then the last thing, literally the last thing, we were almost done, is if I have a table, I need to know what kind of polynomial makes it. And that's going to come in handy when we do polynomial models, because there's different kinds of regression. Y'all remember doing linear regression. We did quadratic regression. Well, it turns out there is also cubic and quartic. They can all go on the same screen. We can compare them as to which one goes where, which one's better. But before I do that, I have to figure out what am I even dealing with. Now, I don't really have room because I was dumb and left those tables on that side. So I'm going to do one of these. There we go. Okay, if I go all the way back, like algebra half, you remember all the way back to algebra half, before we deal with this, this is a line. Write its equation. Argue amongst yourselves. How do you figure that out? It's not uncommon that you'll see that on a ACT. There's a table. It represents a linear equation. What is the equation of the line? How do you know? Puzzle it out.
Right. I feel like I'm wrong. I don't know.
Wait, I'm like that. It's dropped in my I just did literally y2 minus y1 over x2 minus x1 and then just had y intercept.
Such arguments stemming from old school algebra half.
So y is equal to 11.
Anything?
Not really. All I know is x is going up by 1 and then y is going down by 2. Half x minus 1 or minus 2. That's my idea. Is that delta?
Delta means change.
Oh, so y.
It's over there.
1 over 2.
The definition of slope. Slope is a rate of change. Rate of change. How much does the y change for every change in x? Before you ever even learned linear equations, you learned to do this. From here to here, down 2. 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 From here to here, up 1, up 1, up 1, up 1. So that means every y is changing down 2. And they're all changing at the same rate. So I can say that the y's are going to be negative 2 times the x. But I have to figure out where did I start. And by start, I don't mean where does the table start. I mean, what if x was 0? Where do I have to move this rate? If y was 0 or x was 0, I would have a 5. Okay. So we're going to do something similar here. Notice that I went to the y's and I checked. They were all moving the same amount. That's called the first differences. Because I find the difference in my y values, and if they're the same the first time I do it, then it is a linear function, degree 1. So, a little bit of review from back in the day there. I'm going to do the same thing. Be careful, it says differences. I work my way up the table. What is negative 7 minus 9? Negative 16. What is 9 minus 11? Keep doing it. 6, 8, 4, and negative 6. Is that set of differences all the same number? Since this was the first set of differences, that's my check for linear functions. I keep doing this until they are the same. Try again. You say negative 16 minus negative 2. Negative 2 minus 6. Negative 6 minus 8. 8 minus 4. And 4 minus negative 6. Are they all the same? No. This was the second set of differences. But look at what happens when I go to the third. Negative 14 minus negative 8. Negative 8 minus negative 2. Negative 2 minus 4. 4 minus 10. The third set of differences was all the same. So I know that this is a cubic function because the third set of differences was the same. The last time we saw this was all the way back in Algebra half when we were talking about linear functions. The point of it is if I give you a table, you do this successive differences thing, and you'll know whether it's a linear or quadratic or cubic or quartic or quintic or whatever. And once you know what kind of polynomial it is, then we can start doing all the stuff we're going to learn in this chapter to figure out what is the actual equation. You are going to find the equation for this specific table later. But first we got to know what even is it. There's no point in trying to find a line that goes through this data if it's not linear. This is how I determine it's a cubic function. So then I will start with a cubic model and go from there. But I got to know that first. Make a note to yourself. When you do this, you subtract your way up the y's. Go up the table. Because it should be y2 minus y1. Right? Good old slope formula. Y2 minus y1 over x2 minus x1. You take the last y minus the first y kind of thing. So I need to take this minus that, not the other way around. If I were to try subtracting this way, my signs would all be backwards, and eventually they would not end up the same because they would start alternating, like positive and negative values. So it's a cool little tool to determine what type of function it is. Another one of those random grab bag things that might pop up later on a test. So I gotta at least present it to you so later on you can see what's what. Same thing, here's a table, do the successive differences, tell me what kind of function this is. I'm gonna have to rewrite and drag it over. What type of function is this? Subtract your way up the table. First round okay? Subtract your way up the table. Assuming that I can mental math correctly. The first set of differences isn't the same. Not a line. Keep going. But now I'm starting to see some symmetry to it. So I know I got to be getting closer. Second set of differences is not the same. Not a quadratic. Go again. Again, I see that symmetry, but they're not the same. So it's not a cubic. And one more time. Since the fourth set of differences are the same, I know it's a quartic. Okay. At the end? If it's a polynomial, yes.
What's this one? After linear, before cubic?
Quadratic.
Oh, yeah.
It's the first, second, third, and then fourth set of differences, testing whether it is a line, whether it's quadratic, a cubic, or in this case, a quartic. And you keep testing. Now this also starts to get into some fun discrete math, dealing with sequences and series, but we're not ready for it yet. And also my definition of fun might not be the same as yours. Case in point, I showed a couple of my game club kids Caesarean numbers, and they've decided to take it into their own set of numbers, like they're creating their own numerology just because they want to. If I remember right, I think that is a Caesarean-based numeric code to represent Minecraft materials because they're dorks and it's fun because we're just like that. So that's as far as we had gotten. We just missed out on the last example. That means your homework will have 5-1 and 5-2. So, like, it's not going to be a boatload, but because we just missed that last little bit, which honestly, that's my fault because we got talking about like classes and college and all that kind of junk. So that's my fault. I'll make sure that the assignment isn't crazy. So, polynomials. Well, we know what they are now. Linear factors. We saw a bunch of those throughout Quadratic Town. and zeros. When it's written in mathese like this, it can look kind of confusing. You come down here, this is the important part. This notation is going to look kind of scary. This is sequence notation. Put the phones away. Okay, you know what? You two are just not allowed to have phones now. Just stop. Okay. I don't know what degree the polynomial is going to be. So that's why they put an n there. An nth degree polynomial. But if this was like a 5, well, 5 minus 1 is 4. So then if I said x to the n minus 2, well, now that's 5 minus 2 is 3, and so on and so on and so on. What this says is your biggest exponent, then the next one, then the next one, then the next one, all the way down to x to the first and x to the 0. They're saying, hey, x is in descending order. Okay, but it's written as a series. This, see how it's got a subscript on it? Subscripts don't have mathematical operators. It's more like a label. And you've seen that before. Remember that? It didn't mean x squared. It didn't mean y to the first. It meant the second y, the first y. This means the coefficient that goes with the nth term. So if I had y is 3x to the 8th minus 17, 29x to the 7th plus 6, 52x 6 plus 3x minus 1. Like if it was this big long polynomial, then this is n minus 1, n minus 2, all the way down. Okay? This is the coefficient that goes with the 8th term, the coefficient with the 7th term, coefficient with the 6th term. They write it like this because this gives you every polynomial, because I don't know what n is, and I don't know what the a's are, the coefficients in front of them. This is a way to write every polynomial, but it's written as a series, and that's something that we haven't seen for a very long time. The last series you would have seen probably would have been in ProbStats Algebra 1, and I don't even know if you got there, because I think most of you had Algebra 1 and shut down, didn't you? So you just plain haven't seen that before. It's just a different way to write it. But you know this idea of a subscript and a superscript, meaning exponents and just denoting which one. The most common one that you know, right? It's not a mathematical operator. It says two of these. This says the nth coefficient. Okay? So, just got to knock that out of the way. If I got a polynomial, blah, 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 and x minus b is one of its factors, just like if I had x squared minus 2x minus 8. It factors into this, right? Those are called linear factors because x is to the first. Lines, linear factors. If this is a linear factor, then b is a 0. We saw that with quadratics, right? Set that equal to 0, set that equal to 0. We would also call them solutions. We would also call them x-intercepts, because that's why they set equal to 0, is because y is 0 when I solve. And those are also called a root or solution. So they're all talking about the same thing, but in a different way. Kind of like tone changes your meaning when you're talking about, say, a person. Okay? Rylan might say, Dawson. Sounds kind of dismissive or joking. Whereas Brooke might say, Dawson. And then that's got a little different meaning to it. And then Jaden says, Dawson. Okay? They all have a different meaning, but they're all still talking about the same object. B is a 0. It is a root. It is a solution. It is an x-intercept. Okay? They're not all the same context, but they're all talking about the same object. It's important to note that their meaning is going to be kind of switched around and muddied. But again, it's one of those all fingers are thumbs, or all thumbs are fingers, but not all fingers are thumbs things, where they're all talking about the same object, but Dawson. Okay, they're all talking about the same object, but in a different way. What that means is if I can factor quadratics to find zeros and stuff, I can also factor bigger things. Now we're gonna start baby steps. Oh no, it's to the third! What's the first stop on any factor train? Not necessarily A. Greatest common factor, right? What do all three of these terms have in common? So take an x out of there and you will see what's left. And what's left looks awful familiar. Okay. There's a reason that we spend so much time on quadratics. You spend a class and a half on quadratics because everything can be turned into quadratics. This cubic, by factoring out an x, now it's x minus 5, x plus 3 there. I'm now able to factor it into 3 pieces. Okay, now there's no equal sign up there. Stop trying to solve things that don't have an equal sign. I saw that on the Algebra 2 quizzes. I saw that on some of my Algebra half quizzes. If there's no equal sign, don't just randomly set it equal to 0 and go for broke. Like, no, you're done. You factored the thing. Good job. Okay? Speaking of, if we got a little bit of time here, I think everyone took quiz 5 and 6, so I should be able to get those back to you. Go again. First start with your GCF, then factor the quadratic that's left. That's insanely loud. How are you not bleeding?
I don't know.
Who said that? He has them.
It always confuses me with these two numbers.
What's our factoring decision tree from chapter 4? First of all, that guy's gone. You divided by x. You're looking for what times what makes negative 12, but they add together to make negative 1. And if you don't know that off the top of your head, then you just list the factors of 12. 1 and 12, 2 and 6, 3 and 4, 4 and 3. Oh, wait, I'm repeating myself, so I'm done. But then one of them's got to be negative, right, to make that negative 12? So which of these are 1 unit apart? Which one's got to be negative to make it a negative 1? Ta-da! There you go.
I always mess up parts here.
told you guys. No, it's negative 4. Wait, negative 4 is 3. I already had it.
Okay.
I used to erase my 4, but I thought it was plus. It's okay. I can change it 4 times.
That's it. Take out your DCF, factor the quadratic that's left. Okay? All right. Since the linear factors can be set equal to 0 to get me zeros, which are x-intercepts, that means if I have something in factored form, it tells me all of my zeros. It tells me all of my x-intercepts. What are the zeros of this and graph it? Set this one equal to 0. X is what? Is 1, is 3. So I know if those are the zeros or the solutions, then those are the x-intercepts. So I put an x-intercept at negative 2, 1, and 3. If I were to multiply this whole honkin' thing out, remember all of our distribution business, right? I would have an x times an x times an x as the biggest term out front. If I go fast, x plus 2 times, if I multiply those, x squared minus 4x plus 3, distribute that, x to the, nope, x to the third minus 4x squared plus 3x plus 2x squared minus 8x plus 6 minus 2x squared minus 5x plus 6. If I were to multiply it all out, I've got this polynomial. So just, no, you don't have to. I'm saying if you take the first terms of each binomial, this times this times this, it'll get you the leading term. You don't even have to worry about the other stuff. Why would I care about the leading term? The end behavior, right? This is a positive, no, just so casual, just yo. If I know that it's a positive odd polynomial, just because I'll have x times x times x, then I know this thing is going to start down at negative infinity. These are x-intercepts. So it's going to come up through here, through here, through here to go back to positive infinity. Because that's its end behavior. I don't know what it does in the middle, but I know what it does at the ends. And now I know some of what it does in the middle. This would be like, I know Maria is incredibly crabby when she wakes up. I know she goes to this, this, and this class because she tells me about it. But I know she's pretty happy when she gets home. I have no idea what happened at school, but I know the end behavior and I know which classes she has. Okay. Then the conversation needs to be, all right, what happened at school? How did you go from the world must burn to I'm so happy? What happened? That's where your calculator comes in. I would like everyone to jam this, and you do not need to distribute it out. You can type it exactly like this into your calculator. See, I know that this graph is going to go from somewhere down here, through here, through here, through here, but I have no idea how far up or down it's going to go, so don't make that on your graph yet. I don't know how far up or down this thing goes. I'm going to let my calculator help me figure that out. Okay, so there we go. So we're going to say x plus 2, x minus 1, and x minus 3. Okay, I can type it exactly like that. And just to prove to you that I'm not entirely crazy, negative 2, negative 5, 6. I will also say x to the third minus 2x squared minus 5x plus 6, right? Is that what I had? Minus 5 plus 6, okay. So just to show you that I'm not bonkers here, okay? So it's the same thing. The graph will do it no matter what. So I'll get rid of this just so we're tracing on one thing. My graph here, I'll show you a little trick not many kids figure out until pre-calc. Particularly if you're using a TI-84. If you're on an 83, this is going to be kind of gross looking. But if you're on an 84, now I know it's in your menu somewhere. Oh, you just went, okay. I just broke down and conformed. Casios are so good, though. I mean, I understand. We're doing everything on the TIs. I understand. But Casios are actually a superior calculator. It's just, this is what we're using in class. Okay? Everyone who has a TI-84. Second, right above Zoom is format. I can turn my grid lines on. Why would I want to do that? If I turn my grid lines on, I get to see my actual graph. Now, for now, does it do it on there?
Yeah, it does. It just looks like a bunch of random dots.
Yeah.
It's really bad.
That's why I said on an 84, they didn't improve much between the 83 and the 84, but that is a nice feature. You should have seen, if you got a friend who's got the TI Inspire, that thing will graph three-dimensional. Like, it'll do some pretty wicked stuff. Yo, where do you think this is and this is?
8 and negative 4. Oh no, 1.
Now, they're not exactly there. So when we make our graph, this is also the only time you're going to do this in my class. You can go to -1, 8, and say approximately -1, 8. Because I guarantee you it is not. You can go to 2, what was it, -4? Approximately to -4. And now you can connect the dots. The important, hi.
If we have to know what it is, would we be able to find the maximum of it?
There's what's called a relative maximum, and we will get to that in a little bit. That's why I said this is the only time you'll ever do this. This is the only time we're ever going to say good enough. This is just to get to the idea, can you take the zeros and put them on the graph? Okay? Can you take the zeros and put them on the graph? Then fill in the blank. Okay? Here you go. Graph is over here. Notice it's a little bit bigger. I think this might have been one of those times where I actually put a graph on there that was to scale. Now, this is also why we want to have points on our graphs, because unless you are really good at freehand drawing, your graphs are going to suck. Like some of you, they're going to look pretty, nice and curvy. Others, it's going to look like a 4-year-old trying to write his name. Yep, you can plug it in the calculator just like that. You don't have to distribute. Oh.
Oh, 36 on the dot.
I can tell I'm a little clogged up here. I thought Jaden said something about a ginger window. Or no, a ginger winter. It's like... See, the thing about Zoom Fit, it's supposed to zoom to relevant features, but sometimes what the calculator thinks is relevant is definitely not necessary.
Yeah.
Okay. So stage 1, I'll just zoom to a standard. Okay, and you can't see enough, right? So your option is to either manually change the window. You needed the Y's to be taller. So I don't know, negative 30 to 30.
Okay.
I'm just guessing.
So you just change the.
You see where having the grid lines on isn't always good?
Yeah.
What the bejesus?
Oh my god.
Oh, did someone forget an X? Yeah, you did.
Oh.
That's why.
Not bad.
Ooh, still not enough.
Just a little bit.
So another thing you can do is just hit zoom out
Zoom out.
and just say, I want to zoom out, but with that as my center. And it'll zoom out a little bit with that as your center.
Oh, Jesus. Thanks.
Okay. So you can manually change the window, or you can play around with the zoom in out feature. All right. Okay. 0, 3, and negative 5. If I were to multiply the whole thing out, take your leading term times your leading term times your leading term, I'll have a positive x to the third. So I know that this thing is going to start down at negative infinity, head up to positive. Now it's just a matter of finding in between there, how high can you go and how low can you go?
No.
How do you plug it in? That's
What is this?
Mind grabbing me? Because I set my window to a certain spot so it only go.
Who are we staring at? Rugrats. Hey.
We're in. Yeah, I'd ask you. Okay. So I did the grid on, but when I graph it, it looks like that. Which looks so terrible. It hurts my eyes just to look at that. Like, that's weird. Oh, how did you get that? Oh, is it that I went...
I did zoom standard back to a normal 10 by 10 grid.
But then how can I get it so it goes down and it still shows the lines like that?
Honestly, I wouldn't, because of how pixelated it is. I would get rid of that in a heartbeat. It looks like trash on these screens. And then my window, you want it further down. I'd go to like negative 30-ish, I don't know. Close. So you got to keep just moving your window until you can see it.
Okay, so don't do the grid then.
I wouldn't. It helps sometimes, but honestly, it's just going to make it look like trash eventually.
So I have a question.
Mm-hmm.
So like when we like do this, it says like negative, or it says like 1.6. So how do you decide which one you're gonna do when you say like about? Because like, are you gonna go to 1 or are you gonna go to 2? Like, does it matter?
Pause, rewind, repeat. Okay. So, if I try to plug that in, y is thing clear x by x minus 3 by x plus 5. Graph of a. Okay, a couple of things I want to point out. One, the bigger this gets, the more lines my calculator tries to show, the grosser it looks. Okay? Something that you don't really notice, but is entirely possible. If I'm going from, say, I don't know, negative 40 to 40 on a paper, are you going to count by ones?
No, probably like
Fives? Look at the scale. Go by fives. Literally, go by fives. And now, because I'm going by fives, it's going to change my grid lines to only every 5. Now, if I do that, could I now say that this is about negative 3, what's that, 35? I know it is. Okay, could I say this is about 1.5-ish negative 15 when I'm ballparking it? Okay. Now, Alexis, you had a question about it's 1.6 something something. How did you get that? That's it. All right. We're not doing this about business anymore. Instead, if I'm going to graph these, I'm going to graph them correctly. I'm going to say second calculate, and there are minimums and maximums, but they're called relative minimums and relative maximums. It's like my kids in the room all over again.
he's alive. That's sick to know. Oh no.
So anyway, I'm going to find a maximum. It appears to be between negative 6 and 0. I poke the button and I get negative 3, 36. So I won't just wing it. I'm actually going to go to negative 3, 36. 20, ew. 2, 3, 4, 5. You know what? Maybe I just say screw it and go by twos. Right? So we'll go to negative 3. There's 20, 30, 32, 34, 36. Okay. And then Alexis was asking about that one, said, I found the minimum. It appears to be between 0 and 5. Oh, we know what that is. What is 0.6 repeating? 2/3. So 1 and 2/3 is 5/3. And then, okay, let's see if we remember all the way back to one of our earliest things we did in here. Stop watching the bug. Do you remember how I turn 0.818181818181818181 into a fraction? Over that many digits of 9. 81 is the part that's repeating, put it over 99. 2 digits are repeating, 2 digits of 9. 81 over 99 reduces down to 9/11ths. This is negative 14 and 9/11ths. Or negative 154/11ths. Right? Oh, wait, no, and then you got to add 9. And 154 plus 9, negative 163/11ths. Oh, hey, let's say I don't remember how to do any of that. Could I instead quit back here and say point? Could I do get the remix, right? Math, change it to a fraction, please. Okay? Plus 14. 163/11ths. So you can turn it into a fraction without just relying on that decimal. So I'm going to say that this one was at, what was it, 5/3? Stop it.
God. That's a big slip.
So 5/3 and negative 14 and change, so still down there. And say that's about 5/3 negative 163/11ths. Connect the dots, it's still pretty ugly. But I've got the points that matter. Okay? Negative 5/3 and negative 163/11ths, the thing we just found. Okay? So that brings up a important point. Want to make sure I got my, all right. Back here, it's a completely separate section in our book. But I want you to write this now because we've talked about it. Okay. We are not going to just ballpark our points anymore. Because some of us were already headed there, that is a section in here. It's an example in the book in a later section where they talk about this is called Extrema. Okay? Not extra Emma. Right? Extrema is just get the image now of Emma like Kool-Aid Manning through a wall. Just go say hi to, Jeffrey's over there like, oh yeah. I don't know why. It's just my head. We're not just going to ballpark our maximum minimum. We're going to go find them for real. They're called extrema because they are the extremes within a region. They're not the maximum. They're not the minimum. They're just a maximum or a minimum for that area, which is why we're able to find them on our calculator. Okay. So that'll come up again later. But for now, whenever you're graphing these, you know how to plot the zeros. Go find your extrema. You should have your 5 or 6 dots, connect the dots. Okay? They don't have to be difficult. All right. I want us to do one more and find it for real. That one. Plot your zeros. Go find your minimum or maximums as they occur. If you have to change the scale of the graph, it's okay. Terrified, but here we go.
You want me to sue? That's. Why? We don't do that. Okay. I don't know anything about friends. It's not educated. I'll just do it. Probably a lot of free cases. You know what that means? What? I said I would take this. I didn't say it was educated or right. It's a guess, I'm not an educated one.
Just looking at this, where are my zeros going to be? 0, 5, and negative 2. Remember, you set each part equal to 0. I don't see everything, so I'm going to change my window. How far down? That far? Okay. Perfecto. Okay. So I'm going to calculate, because we're not BSing it anymore. We're going to do it for real. We're going to go find our maximum somewhere between negative 2 and 0. Come on now. Okay. So last time we were able to write these as fractions. What do I do now? Round to the thousands, exactly like we just wrote it. So when we round, please don't just put the coordinate. Because you're rounding the coordinate, what should go right next to it? The squiggly equals approximately, okay? Squiggly equals. So we're going to say approximately negative 1.081082 to 6041. Do it again. Go find that one downtown. Second, calculate a minimum somewhere down, I don't know, between 0 and 8. Okay, as long as those two arrows are pointing in, you're good. Now, I heard a couple of you yahoos saying something like, uh-oh, I got error.
We just messed up a little bit.
Define messed up a little bit. Like, I actually want to hear the error, because
We were just trying to get fractions, and you got a number with E and really big.
Okay. A number with E and really big. We've run across that before. What does it mean? Scientific notation. Okay. So again, and I'm going to get extra lazy and just say, because I can, because smartboard. Okay. Remember that whenever you're using these, I know I use them a little heavier in this class than in others. Just be careful with the notation of it. Be careful with how you treat the error messages. If all you see is error quit, you end up in my quote book. Okay, Dylan, I don't know how many years ago. Dude, my calculator told me to quit. That's kind of discouraging. Like, should I just give up on math? No. Y'all know when you get that error message, though, look below it, and it tells you what went wrong. Even better if you have quit and go to. I don't know why they don't separate that. It just says go to. If you have the go to option, it'll actually go to and be blinking wherever you screwed up, usually in the way that you type something. So again, we're not just going to ballpark these. Now we know those are an actual thing I can find, just like with my vertices of the parabolas. All right. Everyone's extra squirrely today. How you doing?
Squirrely.
It's Friday.
Like, can we do another thing?
No.
Yeah.
No more things.
Are you being facetious?
I'm not. No more things.
Not do you want to? Can you?
Uh,
A thing? A thing.
Yeah.
Anything.
Singular.
Emily's over there like, no, no. Okay, it's not a difficult thing. It's distribution. It's exactly what I was doing with that other one when I speed run and did, here's the polynomial. Your turn. Okay? If I say there's a polynomial that has these zeros, well, we just talked about it. If they're zeros, then they're x-intercepts. If they're x-intercepts, then they're roots. If they're roots, then they can make linear factors. So, x minus the 0 is how I make any linear factor. Now, I put a boatload of parentheses up there. I think that's not necessary because you know that you're just going to end up switching the signs on all these, right? So it's x plus 2, x minus 2, x minus 3. Now, before you go distributing, do not be this kid. Why is that bad?
You get a lot more room for error.
Well, all right. Mental math. Mental math. Put that down.
180. 180.
Come on. Okay. It is 180. I want you to pay attention to how you just did it.
15 4 times.
Did you say 15 times 4 is 60? 15 times 3 is 45? 60 times 45 is, wait a minute.
Definitely not.
You do them in pieces, right? Multiply these two numbers, and then whatever that is, multiply by the last one. So that's exactly what we're going to do. Do this in pieces. No. Multiply together. That's exactly what we just said not to do. Multiply the... Hey, cut it. I don't know if you're being facetious or not. If someone has a mathematical question, don't rip on them for it. They're clarifying. Okay? Multiply the first two parts. Whatever you get, multiply it by the last one. Just realized that as I said that, I did this, and then it kind of squished the rat. Poor rat. Come on. Okay. So, x plus 2 times x minus 2. Does anyone recognize the special form? The middle terms are going to go away because they're called something special. Starts with a C, ends with a conjugate.
Conjugate.
Hey, there you go. So we got an x squared minus 2x plus 2x minus 4, right? And the middle terms will cancel. You're right. So I've got x squared minus 4, but then this is still here. So then do it again. Distribute again. Okay, x squared times the stuff is x to the third minus 3x squared. Negative 4 times the stuff. It's negative 4x plus 12. In this case, I don't have any like terms that I have to combine. It just is. Okay. So before I go into any more, before I go on to part B, I want to go old school We did this with, oh wait, no, that was pre-calc. I keep getting where you guys are learning something new mixed up with when pre-calc just reviewed it. If you would, for favor. No, let's do... No calculators. None. None. You can write it, yeah. That's what I want you to do because there's a point to it. There's a method to the madness. Do you remember how to do longhand multiplication? It's kind of important. I'd be really interested to see your paper because I know that the organization is different. Yeah, it is. You do it backwards of the way that we're going to do it. Like it's just it's cool to watch. I like it. Just like how a lot of European countries will use, instead of a decimal, they'll use a comma, and instead of a comma, you use a slash, like for coordinates. So 3,4 is 3/4. Okay, maybe that was the Norwegian kids.
It's like semicolon 4.
It was the Norwegian kids. Okay. But I love seeing how other people do it.
Oh, there's a 0. Do you know how long it's been since
How does it work? How does the other way work?
Okay. Step 1. 1 times 3 is 3. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 2 is 2. 1 times 1 is 1. And then 0 is a placeholder. And say 2 by 3 is 6. 2 by 1 is 2. 2 by 2 is 4. 2 by 3 is 6. 2 by 2 is 4. 2 by 1 is... Whew! And then you add them all together. Why was that 0 important? Placeholders.
Because you're multiplying by 28. Because it's like you're not just 2.
What'd you get? 2,587,473. What'd you get? Not bad. I got it.
You just did that. When I take 1 times 3, I get 3 ones. When I take 1 times 10, I get 1 10. And on and on and on and on. To do 20 times the thing, I just move over because 20 is in the 10 spot. What I'm trying to show you here is that you have been doing long chain multiplication of polynomials since elementary school, but you didn't know it because this, how about 3x, 2x squared, 3x to the third, 2x to the fourth, x to the fifth, times 2x plus 1. Isn't this in descending order? Wasn't this in the tens to the 0 place value? Anything to the 0 power is 1. This is in the 10 to the first. This is in the 10 to the second. This is in 10 to the third, 10 to the fourth, 10 to the fifth, 10 to the sixth. It's descending order of exponents. Our place value system is mimicked in how we set up polynomials, which means you can multiply polynomials any way that you multiply numbers. That's important for part B, because you can multiply part B any number of ways. Start with, write out your zeros. X plus 2, x plus 2, x minus 2, x minus 3. Y'all follow so far?
See.
One of you two is probably getting moved over to that corner. Because every time I'm trying to say something, one of you is flapping your lips. Usually you. Yeah. You write out your zeros. This is no different than if I had 3 times 4 times 5 times 6. I wouldn't distribute 3 into the other stuff. If I had 3 times 4 times 5 times 6, I would turn that into 12 times 30. These two together, those two together, then those products together. Do the same thing here. If I take x times this stuff, x squared plus 2x, 2 times this stuff, 2x plus 4, is x squared plus 4x plus 4. If I take x times x, x squared, x times negative 3, negative 2 times x, and negative 2 times negative 3, I get x squared minus 5x plus 6. And I still have to multiply together these polynomials. I multiply them no different than the number 144 times 156. Now, there's differences in signs. Here, if I ever hit a grouping of a place value, I would then go into the next place value, right? I can't do that with these because I don't know how many x's equal an x squared right now. So I'm saying there's an analogy between them where they're similar. Meaning, I just want to organize it. If I can organize my distribution from back in elementary, I can organize my distribution here. Take the x squared times that stuff. I get x to the fourth minus 5x to the third plus 6x squared. Cool?
Yes.
X squared times that stuff. Just distribute. If I take 4x times that stuff, don't write this yet, I would get 4x to the third minus 20x squared plus 24x. If I took 4 times that stuff, I would have 4x squared minus 5x plus 24. And you say, why'd you tell me not to write this? If you have this big, long blah, 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 across your paper, isn't it kind of annoying to find the like terms?
Yes.
Versus, what if I organized my data as I was writing it? What if I kept things lined up by place value, just like I do with longhand multiplication. Because now my function is 1x to the fourth minus 1x to the third minus 10x squareds plus 19x's plus 24. Look at how much easier it is if you line them up. Did I math wrong? Negative 5x? Oh, that's negative 20x. Good call. Like that. Good call. Where's black? I should just leave it over there. But do y'all see what I mean by if I keep things lined up, if I'm willing to take a little more vertical room, it'll keep all of my like terms together. Okay, now I know we got a lot of people in biology. I'm about to kind of annoy you, but some people like this, some people don't. Ahem. Couldn't I write it out like a big honkin' Punnett square? Some kids absolutely love this because it's in rows and columns and it's organized and my brain can look at it and know what came from where. Some kids absolutely love this. Others have some form of trauma from biology and they don't want to see this ever again. Yeah, it depends on you. But I'm still going to have x squared times x squared is x to the fourth is 4x to the third is 4x squared. Don't quit just yet because there's a fun thing real quick. Take a look at the diagonals of it. The diagonals are my like terms. There are so many ways to organize regular multiplication, so there's going to be a bunch of different ways that you can do these problems. It's literally on YouTube. You can take a screenshot of it on your phone, dude. Okay. Here's them.
I don't understand the math to get to here, like without those. I don't know if
Oh, I was adding the columns.
Yeah.
Like terms.
I was just.
So 1x here.
Oh, okay. I keep cutting that one out.
Okay.
So my numbers.
That's why I organize them this way. Okay. So. Our playlist. So website or plan book, wherever. The first one? Okay. Oh, yeah, expressions and equations. After all this time, you're going to crush it. So if you just go to any of our videos, it brings you to at least the channel. So if you poke my head, not with anything sharp, under playlists, there's your class. That's also on the website. So
And then just find.
Scroll to review quiz 1.
Sweet. Thank you.
Okay.